The question is how to find out the private savings in an economy. Question is like this: consider the economy described by the following: y is equal to c plus I plus g, where y is the income, c is the consumption expenditure, I is the investment expenditure, and g is the government spending. With the value of total income is equal to 5,000, government expenditure is 1,000, and t denotes the tax revenue, which is 1,000. Our consumption function is c is equal to 250 plus 0.75 y minus t. 250 denotes the autonomous consumption when the level of income is 0. 0.75 denotes the marginal propensity to consume, and y minus t denotes the disposable income. Where the symbols have the usual meanings, we need to find out the private savings in this economy. Okay, so private savings, if I write it here, private savings, that is denoted by P in an economy, is given by, that is equal to our total income minus the consumption expenditure minus the tax revenue. Okay, that means our P will be equal to, what is our total income that is being given us is 5,000 minus consumption expenditure is, if I write it like this, so we have 250 plus 0.75, then y, again it is 5,000 minus tax revenue is 1,000. To this we subtract the taxes that are being given us as 1,000. Okay, so private savings will be equal to 5,000 minus, we have 250, or let us first solve this, plus 5,000 minus 1,000 is 4,000. Now 0.75 was 75 upon 100 into 4,000, so this gets cancelled, so we get 0, 4 7s are 20, sorry 4 5s are 20, 4 5s are 20, 4 7s are 28, 29, 30, so we get here 3,000. So this term becomes 3,000. To this we subtract 1,000. That gives us private savings will be equal to 5,000. Then we have 3,000 plus 250, so it becomes minus 3,250. To this we subtract 1,000. So private savings will be equal to 5,000 minus, so let's add these two, so it becomes 4,250. So private savings will be equal to 0 goes 0, 10 5 5 9 7 0 goes 0. So private savings in this economy will be equal to 750. The question is how to find out the value of the learners index. The question goes like this: learners index, a measure of market power, is defined as price minus marginal cost upon price. If the profit maximizing firm passes the demand curve as P square Q is equal to 7, where P and Q denote price and output, we need to find out the value of L. Okay, so we are being given the learners index. Okay, by learners index, what we mean, it is a measure of market power, the ability of a firm to charge price above the marginal cost. We call that what we call the market power, and the relationship is, that is learners index is equal to price minus marginal cost upon price, which is equal to the absolute value of elasticity of demand. This is the relationship. We need to find out the value of L. So to find out the value of L, let us first find out the value of elasticity of demand. So we are being given the demand function as P square Q is equal to 7. Let us solve this for Q. So Q will be equal to 7 upon P square. We can write it like this: 7 times P raised power minus 2. Now elasticity of demand, as we know, it is simply the change in the output due to the change in the price times price divided by output. So dq upon dp, let us first find out this, minus the derivative of this function with respect to price. Using power function rule, exponent becomes coefficient, so 2 into 7 is minus 14 here. Okay, so we have then p and exponent is subtracted by 1, so we get minus 14 p raised power minus 3. This is our what we call this derivative. Then elasticity of demand will be equal to elasticity of dq upon dp, which is equal to minus 14. Let us write it like this, p cube here. If I transpose this, it becomes positive, the exponent. Okay, times p divided by q. Q is this function, that is 7 upon p square. Let's further solve this. So we have minus 14 divided by p cube into, so here we have p transpose, it gets multiplied here, so it becomes p square divided by 7. So we will get elasticity is equal to 7 ones are 7 twos are 14, so we get minus 2 divided by p cube into p square is p cube. This gets cancelled, so elasticity of demand is minus 2, absolute value of elasticity of demand is 2. Okay, having said that, so we have this relationship, price minus marginal cost upon price is equal to this stuff. So can I write price minus marginal cost upon price is equal to 1 divided by elasticity of demand is 2. Okay, so 1 upon 2 is equal to 0.5. If L is equal to this stuff and this stuff is equal to this, simple thing, so it means this is equal to, L is equal to 1 upon elasticity of demand. So elasticity of demand is 0.5, that means the learner's index will be the reciprocal of the elasticity of demand. Sorry, elasticity of demand was 2, so learner's index will be 0.5. The question is to find out the absolute elasticity of demand from the given demand function. The question is, demand curve for a commodity in your consumption basket is given by p square q raised power 5 is equal to 392.67, where p denotes the price, q is the quantity. The absolute value of your own price elasticity of demand for this commodity is we are supposed to find out. So we are being given the demand function as p square q raised power 5 is equal to 392.67. We need to find out the elasticity of demand. So we know that elasticity of demand in absolute terms will be equal to the change in the quantity demanded due to the change in the price times price upon quantity demanded at that very price. So first we need to find out this derivative dq upon dp. For that we need to solve this function for q. So can I write q raised power 5 is equal to 392.67 divided by p square. Okay, then since I only need q, so can I write q is equal to, transpose this, it becomes 1 upon 5 as exponent. So we will get 392.67 divided by p square whole raised power 1 upon 5, or q will be equal to 392.67 raised power 1 upon 5 divided by p. So we have 2 into 1 upon 5, which becomes 2 upon 5. Now we can find dq upon dp. So dq upon dp will be equal to derivative of this function with respect to p. Or if I further solve it here, so can I write it like this, 392.67 raised power 1 upon 5 times p raised power minus 2 upon 5. Okay, exponent sign changes when I transpose it here. Now the derivative of this function with respect to p, exponent of p becomes coefficient, so we have minus 2 upon 5 times 392.67 raised power 1 upon 5 times p raised power, exponent is subtracted by 1, so we have minus 2 minus 5, which is minus 7, sorry, minus 2, and minus 5 is minus 7 upon 5. Okay, now elasticity of demand, as we know, it is equal to dq upon dp. So elasticity of demand will be equal to dq upon dp, which is this stuff, which is minus 2 upon 5 times 392.67 raised power 1 upon 5 times p raised power minus 7 upon 5. To this we multiply by p divided by q. Q is what is q? Q is this very function. Okay, so can I write it like this? So q is 392.67 raised power 1 upon 5 divided by p raised power 2 upon 5. Solving further, first this 392, this gets cancelled, so we get minus 2 upon 5. Then we have p raised power minus 7 upon 5 into p, so it gets multiplied, it becomes into p raised power 2 upon 5. So we get minus 2 upon 5. Bases are same, we can add the exponent. So we have minus 7 upon 5 plus 1 plus 2 upon 5. Okay, so can I write it here? Multiplying numerator and denominator by 5, so we have minus 7 upon 5. In place of 1, can I write 5 upon 5 plus 2 upon 5. So we have the same denominator, so let's write 5. Here we have minus 7 plus 5 plus 2, so it becomes minus 7 plus 7 divided by 5, so which is equal to 0 upon 5, which is equal to 0. So this stuff will be equal to p raised power 0. So anything raised power 0 is 1. So we get elasticity of demand is equal to minus 2 upon 5. But we are supposed to find out the absolute value of the elasticity of demand, which is minus 2 upon 5, which is equal to 2 upon 5. And 2 upon 5 is, what is 2 upon 5? So 2 upon 5 is, we have 2 here, 5.0, 5 4s are 20. So we have 0.4 as the absolute value of price elasticity of demand for the given commodity. The question is to find out the present value of perpetual cash flow. The question is, the present value of perpetual cash flow of $200 discounted at the rate of 10% each year is, we are supposed to find out. Now the present value of a perpetual cash flow is calculated by dividing the annual cash flow by the discount rate. Okay, so present value of cash flow will be equal to, so we have 250, which is the annual cash flow, 250. To this we divide by the discount rate, which is being given us as 10%. So which is equal to 250 divided by 10 divided by 100, which is equal to 250 divided by 1 into 100 upon 10. This gets cancelled. Our present value of perpetual cash flow will be 250 into 10, which is equal to 2500. The question is to find out the unemployment rate. The question is, the composition of adult population in an economy is as follows. Employed person is 140 million, unemployed persons are 10 million, not in labor force is 50 million. We are supposed to find out the rate of unemployment. Okay, so unemployment rate, if I write it here, unemployment rate is equal to, that is equal to the number of unemployed person, that is unemployed, divided by the sum of the employed and unemployed, that is employed plus unemployed into 100%. Okay, so unemployment rate in this case is unemployed is 10 million divided by employed plus unemployed is 140 plus 10, which becomes 10 divided by 150. To this will multiply by 100%. So this will come out to be 6.67, I guess. So this should be the correct answer. That is 6.6%. 6.67% will be the unemployment rate. Question is how to find out the monthly average price. The question is price of milk of certain brand was 28 rupees per liter and 36 per liter in the months of September and October of 2015 respectively. Assume equal amounts of money is spent on that brand of milk by a particular family in each of these months. The average monthly price of milk paid by this family during these months is we are supposed to find out. Okay. So price of milk for October. So for, let me write it here, for September is 28 rupees. For October it is 36. Okay. We are also being told that this family spends equal amount of money for the consumption of milk for September and October. Let us take any arbitrary number. Let us suppose this family spends amount spent each month, or amount spent each month is 100. Okay, that means 100 for October and 100 for September. Okay. Therefore, number of liters bought for September, okay, for September, let us write me the superscript S is September, will be equal to the amount spent, which is 100, divided by the price of milk, which is 28. This will be the number of liters bought in the month of September. Similarly, number of liters of milk bought in the month of October will be equal to the total amount spent, because this family spends equal amount in each month. So it is 100 divided by the price of milk, which is 36. Now average price of milk for September and October. I am doing this superscript to show September and October. This is not any standard notation of showing this stuff. For the sake of simplicity, I am doing it here. Okay, will be equal to, what will be the average price of the milk then for the months of September and October? It will be equal to the total amount spent in these 2 months divided by the total amount of milk bought. So that will be equal to total amount spent okay, that is September plus October divided by the total amount of milk bought for these months September and October. That will give us the average price. So average price will be equal to, so total amount spent is, for the month of September it is 100, for the month of October it is 100. Total amount of milk bought is 100 divided by 28, and we have 100 divided by 36. Okay, solve it. So average price will be equal to, so 100 plus 100 is 200 divided by, this gives us 3600 plus 2800. So we have 3600 plus 2800 divided by 28 into 36. Okay, when you solve this, it is pretty simple. Average price will come out to be 31.5 rupees. Okay, the question is to find out the income elasticity for the given utility function. The question is, consider a consumer with the utility function. Utility is a function of two goods x and y, which is equal to y plus under root x, where x and y are the quantities of two commodities consumed. Which of the following is true? Options are: income elasticity of demand for both the goods is equal to 1, income elasticity of demand for good x is 0, income elasticity of demand for good y is 0, and last option is income elasticity for good x is 0.5 and for good y it is 1. We need to find out the correct option. Okay, so we are being given the utility function. Utility is a function of two goods x and y, which is equal to y plus under root x, can be written as x raised power 1 upon 4. Okay, so this is actually our quasi-linear utility function. Okay, so our endeavor is to find out the demand function for x and y. Then we can find out the income elasticities. Okay, so our endeavor is to maximize utility, which is equal to y plus x raised power 1 upon 2, subject to the budget constraint, that's price of x times units of x plus price of y times units of good y should be equal to the income of the consumer. So for optimality, we know that we equate marginal rate of substitution between good x and y, and it should be equal to the ratio of the prices. Okay, so MRS, as you know, it is MUX upon MUY. It should be equal to PX upon PY. MUX means the change in the utility due to the change in the consumption of good x. MUY means the change in the utility due to the change in the consumption of good y should be equal to price of x upon price of y. Now derivative of this function with respect to x gives us, that is the derivative of y will be 0 because we are taking partial with respect to x, so it is 0. So we get here 1 upon 2 x raised power minus 1 upon 2, the derivative of x raised power 1 upon 2 here. Okay, divided by derivative of y is 1, should be equal to px upon py. Okay, so we got here 1 divided by twice x raised power 1 upon 2. If I transpose it to the denominator, which is equal to px upon py. Okay, solve for x. So can we write it like this: 2x raised power 1 upon 2 is equal to py upon px, or x raised power 1 upon 2 is equal to py upon px times 2, or let's write it here twice, or x will be equal to transpose under root, it becomes square, so we get 4 py square divided by px square. This is the demand function for good x here. Now demand function for good y is, plug this value somewhere, or plug this value into the budget constraint, that is, so p will be equal to, so price of x times the value of x is 4 py square divided by px square. Okay, I hope I am within the limits. So okay, this stuff here, so px times x is this, plus py times y is equal to m. Solve for y, so y will be equal to, so here 1x gets cancelled, so we get 4 py square divided by px plus py times y is equal to m, or py times y is equal to m minus 4 py square divided by px, or if I write it here, y will be equal to, transpose this, it gets divided, so m divided by py times 4 py square divided by px. Okay, so this is the demand function for good y. This denotes the demand function for good x. This is actually our quasi-linear utility function. What is meant by quasi-linear utility function? I have explained it in my earlier videos. You can check it out. I don't have time and space here to show that very thing. So what is the elasticity of demand formula for good x? So elasticity of demand is the change in the consumption of good x due to the change in the income times income upon x. Okay, now if this is our demand function, its derivative with respect to income is 0 because income is not here, m is not here. That means this will be equal to 0, that is this derivative will be equal to 0. So elasticity income elasticity of demand for good x will be equal to 0 times m upon x. So elasticity of demand for good x will be equal to 0. So let us see if we have that very option, then we can discard the other option. So elasticity of demand for good x is 0. So this option must be correct. Okay, I hope I am making myself clear. Question is to find out the value of the determinant a raised power 5 in the question. The question is matrix A is 4, 12, minus 1, minus 3. The value of the determinant a raised power 5 is we are supposed to find out. So we have the matrix A is equal to, which is equal to 4, 12, minus 1, minus 3. We are supposed to find out a raised power 5, its determinant. Okay, this is we are supposed to find out. Now the property of determinant, one of the properties that if we have a, that is if we have a raised power n, the determinant of a raised power n is in fact equal to the determinant of a whole raised power n. By this what we mean? So we have a raised power 5. It can be written like this, whole raised power 5. So let's first find out the determinant of a. So determinant of a, let us find out. We multiply these two elements first. Okay, principal diagonal element, that is 4 into minus 3. From this we subtract the product of the non-principal diagonal elements, that is 12 times minus 1. So it becomes minus 4 into 3 is minus 12, minus 12. Okay, then we have minus 12 into minus 1 is minus 12, minus into minus is plus 12. So we get here 0. That is we got determinant of a is equal to 0, and we are supposed to find out the determinant of a raised power 5, which is equal to 0 raised power 5, which is equal to 0 in this case. The question is, suppose utility function of a consumer is, utility is a function of two goods x and y, which is equal to x times y, where x and y are quantities of commodities consumed. If price of x is $1 and price of y is $2 and income of the consumer is $100, we need to find out the utility maximizing quantity consumption of good x. Okay, so what we are being given here, we are being given the utility function, that is u is a function of, utility is a function of two goods x and y, which is related with the function x times y. Okay, price of good x is $1, price of good y is $2, that is being given. Also income of the consumer is $100. Okay, we need to find out the utility maximizing quantity. Okay, so that means our endeavor is to maximize the utility of the consumer, that is equal to x times y, subject to the budget constraint that he is facing. What is the budget constraint? That is price of x times units of good x plus price of y times units of good y should be equal to the income of the consumer. Price of x is 1, so we can write x here, plus price of good y is 2, so we can write 2 times y should be equal to the income of the consumer, which is given here 100. Okay, so consumers endeavor is to maximize his utility subject to the budget constraint. Graphically it means, if I draw a simple graph here, we have units of good x on the horizontal axis, units of good y on the vertical axis. Okay, with the given budget constraint, let's draw here. This is the budget constraint. Consumer wants to achieve highest possible satisfaction. Okay, let us say this is IC1, this is IC2. So at optimality or utility maximizing condition, what happens? Consumer will reach to that very indifference curve where it is tangent to the budget line. Okay, so this is the point where they are tangent to each other. A tangency, we know that means first order condition for optimization in this case requires that the marginal rate of substitution between a good X and Y should be equal to the ratio of the prices, price of X upon price of Y. Okay, that means what's MRS? MRS is slope of IC, and PX upon PY is slope of budget line. Okay, so MRS is simply the marginal utility of X upon marginal utility of good Y. It should be equal to the ratio of the prices. MUX is simply the change in the utility due to the change in the consumption of good X, and similarly MUY means the change in the utility due to the consumption of good Y should be equal to the ratio of the prices. Okay, du upon dx means the partial derivative of utility function with respect to x. So derivative of x is 1, we are left with y, divided by du upon dy means derivative of the utility function with respect to y, so we are left with x. Price of x is 1 and price of good y is 2. Solving for this, so we get x is equal to 2y. Now what we do, we plug the value of x is equal to 2y into the budget constraint. Okay, so we have here, that is in place of x we have 2y, plus then we have 2y should be equal to the income, or 4y is equal to 100. Dividing both sides by 4, we get y is equal to 100 upon 4, which comes out to be 25. Okay, but we are supposed to find out the value of x, utility maximizing quantity of x. So plug y is equal to 25 in this equation. That means x will be equal to 2 times what we have done here, we got the value of x is equal to okay, that is correct. X is equal to 2y means x is equal to 2 times the optimal value of y. If I write it here, it is 25. So x will be equal to 2 into 25, which is equal to 50. So 50 will be the optimal consumption of good x. Next question is, a monopolist produces a product and sells to two types of buyers, A and B. The inverse demand function for A and B are P is equal to 50 minus 5Q. P is the price, Q is the quantity of output, and P is equal to 100 minus 10Q. This is for the second buyer, which is B respectively. The monopolist's cost function is C is equal to 90 plus 20Q. The profit maximizing output of the monopolist for buyer B is, we need to find out. Okay, so we are being given the monopolist. We have two buyers. A, for A the demand function is, that is P is equal to 50 minus 5Q. For B the demand function is P is equal to 100 minus 10Q. Also cost function for the monopolist is 90 plus 20Q. Okay, we need to find out, if the monopolist wants to maximize profit, how much amount of output the monopolist should produce for buyer B. Okay, so we know that for profit maximization in case of what we call monopoly, we equate the marginal revenue for buyer B should be equal to the marginal cost. Okay, first we need to find out the total revenue for buyer B. So total revenue will be P into Q. So P is being given for buyer. We are being given P is 100 minus 10Q times to this we multiply by Q. Okay, so I am within the limits. So total revenue for buyer B will be equal to 100Q minus 10Q square. Marginal revenue for buyer B will be equal to the derivative of total revenue for buyer B upon the derivative of the output. So differentiating this with respect to, so we have to use the simple derivative, not partial here. So we differentiate it with respect to Q. Derivative of Q is 1, so we are left with 100 minus derivative of Q square is 2Q, so 2 into 10 is 20Q. This is the marginal revenue for buyer B. Similarly, we need to find out the marginal cost. Marginal cost is the change in the total cost due to the change in the output. So we differentiate this cost function with respect to Q. So derivative of a constant is 0, derivative of Q is 1, so we are left with 20. Now equating marginal revenue with the marginal cost. Marginal revenue is 100 minus 20Q, and we equated the marginal cost which we got is 20. Solving further, transpose this here and this there, so we get 100 minus 20 is equal to 20Q, which implies 80 is equal to 20Q, rather 20Q. So we got 20Q is equal to 80, dividing 20, dividing both sides by 20. Q will be equal to 2 1s are 2 4s are, so Q will be equal to Q will be equal to 4. Okay. Next question is, suppose the GDP growth rate is 8% and the rate of savings in the economy is 40%. The incremental capital output ratio is we are supposed to find out. Okay. So we are being told that growth rate of the GDP for the economy is 8% and savings rate is equal to 40%. Okay, we need to find out the incremental capital output ratio. Now what is incremental capital output ratio? It is simply the ratio of the investment and growth. That is, we know from Harrod-Domar model. One of the assumption is that savings is equal to investment. That means the incremental capital output ratio is simply the ratio of savings and growth. The formula is being given, that is growth rate is equal to savings rate upon incremental capital output ratio. Growth rate is 8%. Savings rate is being given as 40%. And we are being supposed to find the incremental capital output ratio. Multiplying this with this, so we get 8% times ICOR is equal to 40%, which gives us ICOR will be equal to, transpose this here, it gets divided, so we have 40% divided by 8%. Okay, so so it should be like this. Okay, now I am within the limits, so ICOR will be equal to 8 1s are 8 5s are. That means incremental capital output ratio for this economy is 5. Okay, it simply means ICOR means we need 5 units of money or $5 or 5 units of currency to make 1 more unit of output for the economy. Next question is, suppose an economy produces 100 kg of rice in a year and sells that for $100 per kg. if the quantity of money in the economy is $500, then the velocity of money is, we need to find out. So by velocity of money, what we mean? By velocity of money, we mean, or rather we denote it by V. Velocity of money measures the number of times one unit of currency is used to purchase goods and services within the given period in an economy. That is, velocity of money measures the number of times one unit of currency is used to purchase goods and services within a given period. Okay, so let me rub this out. To find out the velocity of money, here we are being given, so we use the quantity theory of money. To cut it short here, so according to the quantity theory of money, the relation is, that is, money circulation or money supply times velocity of money is equal to price level times the GDP. Here GDP is output here, that is 100 kg. So money supply is being given as the quantity of money, that is the money supply is here 500 times V should be equal to, what is the price? Price is rather 100 times the output produced is 100, which implies 500 V is equal to 1, 2, 3, 4, or V will be equal to, dividing both sides by 500, or we have divide by 500, you go yes side, 10 into 10 is 5 into 20. So okay, so velocity of money is equal to 20 in this case. Okay, I hope it's clear to you. Next question is related to Nash equilibrium. The question is the sum of payoffs to the players in the Nash equilibrium of the following simultaneous game is, we are being given the payoff matrix for two players. We have two players, player X and player Y, and their strategies are cooperate or not to cooperate. And similarly for player Y, we have cooperate or not to cooperate. Payoffs are being given in the cells. The first element in each cell denotes the payoff for player X, and the second element in each cell denotes the payoff for player Y. Or let me write it here with another color. So we have here 40, here we have 30, here we have 20. Okay, so the black number denotes the payoff for player X when she or he chooses a specific strategy, and similarly the red ones are the payoffs for player Y when she or he chooses a specific strategy. We need to find out the Nash equilibrium in this case, and we need to add the payoffs of the players. So let's first find out the Nash equilibrium. By Nash equilibrium, what we mean, Nash equilibrium is a situation in which a player chooses his best strategy given the other person or player has also chosen his or her best strategy. And where does this happen in this question? So how do we solve? Let me explain that very stuff here. So let us suppose player X cooperates. Okay, so when player X cooperates, player Y has two choices, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate gives him 30 as payoff. Obviously 50 is greater than 30, so let us underline this. Likewise, let us see when player X chooses to not to cooperate. Again, player Y have two options, either to cooperate or not to cooperate. Cooperate gives him 40 as payoff, not to cooperate gives him 20. Obviously 40 is greater than 20. Since we assume that the players are rational, they will choose higher payoff. Now let us see from the perspective of player X when player Y has chosen to cooperate. When player Y chooses to cooperate, again player X has two options, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate as 30. Obviously 50 is greater than 30. He will choose to cooperate. Symmetrically, when player Y chooses not to cooperate, again player X has two options, either to cooperate or not to cooperate. So cooperate gives him 40, which is greater than 20, so she or he will choose 40. Now where does the Nash equilibrium exist in this question? When both the numbers in a particular cell are underlined or encircled or whatever you call, that will give us the Nash equilibrium. Nash equilibrium cannot be Pareto-optimal at times, okay, but it is the best strategy for both the players to cooperate in this simultaneous game. Now we need to find out the sum of the payoffs. So sum of the payoffs will be at Nash equilibrium, which is 50 plus 50, which is equal to 100 in this case. Next question is the derivative of y is equal to x raised power e raised power x at x is, we need to find out, okay, the derivative. So we have y is equal to x raised power e raised power x, okay. Let us first take the log on both sides, okay. That means log of y is equal to, now what is log of x raised power e raised power x? So e raised power x will become first coefficient times log of x, okay. Or let me write it with another color. We have log of x here, okay. This is our okay. So now let us differentiate it. So the derivative of log of y is, we know it is 1 upon y dy upon dx. Now on the right hand side we apply the product rule, that is we write the first function e raised power x and take the derivative of second function, which is log of x, plus then we write the second function log of x and take the derivative of the first function, which is e raised power x, okay. So let me use the proper color here. We have e raised power x, here we have also e raised power x, okay. So we have 1 upon y dy upon dx, okay. Let me put it like this, is equal to, now we have e raised power x, derivative of log of x, we know it is 1 upon x, color combination की तेल लेने plus log of x times the derivative of e raised power x is e raised power x, okay, times e raised power x, we know that very thing. Then dy upon dx will be equal to, transpose this y, it gets multiplied, so we have y times e raised power x divided by x plus log of x times e raised power x, or dy upon dx is equal to, y is this function, the given function x e raised power x, then we have e raised power x upon x plus log of x times e raised power x. Okay, but we need to find dy, the derivative dy upon dx when x is equal to 1. Plug the value x is equal to 1 here. So we have 1 raised power e raised power 1, then we have times e raised power 1 divided by 1 plus log of 1 times e raised power 1. So we have 1 raised power anything is 1. Okay, then we have e raised power 1 plus log of 1 is 0 times e raised power 1. So we get here so 1 into something is something, so we have e raised e plus 0, which is equal to e, and the value of e is, I guess, 2.71. Okay, so the correct option should be 2.71 here.